Now, 12.7, we're going to be using some rules. We're going to learn how to solve for log. One thing I'm going to say is if I have two numbers, let's say x and y, I can bring them as powers of the same base. I can come out with another example. Same thing backwards. If I have two numbers that have the same base, I can just let the exponents equal each other. And we're going to say that if I have two numbers, rule number 3, if I have two numbers that are equal themselves, I can do the logs of each, and that's going to be okay. And the same thing, if I have two logs that are equal themselves, they have the same base, I'm just going to say it in this case that x is equal to y. Let's take a look at more as an example. We're going to solve for this. So one thing that I can do is I can use the log of both sides. I can say that log of 3 to the x is equal to the log of 12. And the reason why I did that, because we learned that on logs, the exponent comes to the front. So I have that x times log of 3 is equal to log of 12. To get x by itself, let me divide both sides by log of 3. So I have that x is equal to log of 12 divided by log of 3. Do not simplify the 12 into 3. Just type that in, log of 12 divided by log of 3. And you should get about 2.262. One thing I want to emphasize, log of 12 divided by log of 3, it's about 2 point something. If I would have simplified and I would have gotten log of 4, I get a different number. So do not simplify those numbers. All right, let's take a look at this case. Now, because I have an e, I'm not going to use just log. I'm going to use, in this case, natural log. So I have that ln of e to the 0.003x is equal to ln of 40. I know the exponent comes to the front, so I have 0.003x natural log of e is equal to natural log of 40. Natural log of e is 1. There is multiplication, so basically that's not going to do anything. So I have that 0.003x is equal to natural log of 40. So divide by the decimal, we should agree that x is equal to natural log of 40 divided by 0.003. So let me type that in on my calculator. Natural log of 40 gives me 3.68 and some more numbers divided by 0.003. I get that x is equal to 1,229.626. Now we're going to use this, but I already have a base on my log. So let me rewrite this as an exponential form. One thing on the instructions when I say give the exact solution, there's a big chance you're going to have a radical sign. So let me write this as an exponential form. 2 to the 4th is equal to x plus 5 to the 3rd. I know 2 to the 4th, I can do that. 2 to the 4th is 16. So I have that 16 is equal to x plus 5 to the 3rd. I want the x by itself, so I want to get rid of the power third, and I'm going to do the cube root. Now, on the cube root of 16, I'm going to simplify that as the cube root of 8 times the cube root of 2. Because I want to split into two cube roots where one of them is a perfect cube root. And I know this is x plus 5. Once again, the cube root and then the cube cancel out. So I have that 2 times the cube root of 2 is equal to x plus 5. So I'm going to say that 2 times the cube root of 2 minus 5 is equal to x. Notice that for my last step, I brought my plus 5 to the left. That's a minus 5. Now this one, I'm going to condense this. I see that on the left side, I have a minus, but I'm using log base of 2 of both of them. So I'm going to simplify this as log base 2 of x plus 1 over x. And this thing says is log base 2 of 7. I'm using the same logs, so I'm just going to say that x plus 1 over x is equal to 7. Let me get rid of fractions. I'm going to multiply both sides by x just to get rid of the fraction here. So I get that x plus 1 is equal to 7x. Let me subtract 1x. So I get that 1 is equal to 6x. X is equal to 1 over 6. Now on the x's, when it comes to log, when we're dealing with log, my x has to be greater than 0. If it's less than 0, it doesn't work, because remember the graph of log looks like this. My domain, my x values are more than 0. So 1/6 sounds about right. Now let's take a look at this one. I'm going to condense it. I see a plus. I'm going to do multiplication. So I have the log of x times x minus 21 is equal to 2. I'm going to condense this, or I see log base 10, so I'm actually going to write it in exponential form. I have the 10 squared is equal to x times x minus 21. I know 10 squared is 100. To get rid of parentheses, distribute the x. So I get x squared minus 21x. I'm just going to move the 100 to the right because I want to factor this. I have x squared minus 21x minus 100. I'm looking for two numbers that multiplied equals negative 100. When I add them equals negative 21. I'm thinking of this as negative 25 times 4. So my factored is x minus 25, x plus 4. I know that when I solve this, my values of x are either going to be positive 25 or negative 4. However, because I'm dealing with logs, x cannot be negative. So my solution is x equals 25. I cannot accept a negative number. Now we're going to be looking at compound interest. This is in class, I'm going to talk about how it is used, or when is it used. So I'm going to give you guys a formula. It's going to be A equals P. P is just for the principal, how much money we deposit, how much money we start. So this is principal. R is the rate, which is usually shown in percentage. N is how many times it gets compounded per year. So we're going to say N times a year. Don't have much time left in this video, so I'm going to do a part 2.